addition angle identities. Okay, so these are given in the formula book, so you don't need to memorize these. Be careful with the signs. The plus is on the top here, so the sign on the top here is a plus, so they go together. The plus is on the top here, the minus is on the top, so they go together. The plus is on the top, the plus is on the top, the minus is on the top, so they go together. Which means the minus here goes with that minus goes with that minus goes with that minus, and that plus. Now there's a video proof for these identities in a separate video. These identities are also referred to as the compound angle identities or formulae. Example 1, we need to simplify sine 30 plus theta. What you can't do is this. It's not about expanding brackets and thinking, oh, this is going to be sine 30 plus sine theta. This is wrong. We have to use this identity. We've got sine and we're using two angles. We've got a plus, so if you have a plus here, we have a plus on this side. So 30 degrees is angle A, so we need to put 30 here and here, and then theta is B, so we need to put theta here and here, so we get this. Now there are some terms that we can simplify, so sine 30 and cos 30, you can get the exact values from your calculator like this. So sine 30 is a half, cos 30 is √3/2. We're using a trig function on the calculator, so make sure you're working in degrees because we have angles in degrees. And if you want to check whether your final answer here is correct, we can use any value of theta. So for example, theta equals 23 degrees. If you put 23 here, so you've got sine 30 plus 23, which gives us this value, this sine ratio. So sine 30 plus 23 is 0.798 and so on. And then if I enter all this with theta as 23 degrees, I'll get the exact same value. Okay, part 2, sine phi minus pi, and pi is an angle in radians. So again, using this identity, so the minus there goes with the minus on this side, and angle A is phi, so I need to put phi here and here, and angle B is pi, so I need to put pi here and here. So I've got this, and we can simplify cos pi, we can simplify the sine pi as well. We need the calculator in radians mode, so selecting radians, and then cos pi is minus, so this is -1 times sine phi, so minus sine phi, and this term here, sine pi, is 0, that's 0 times cos phi, so this is all 0. So now we have this. Again, if you want to check, and this is not a necessary step, but if you want to check your final answer, make up a value for phi, and I'm using 1/3 pi, I've just made that up, and substitute that in here and work out the value of this, and then substitute the same value in here and work out the value of this, and you'll find it's the same answer. So minus √3/2 for this, and the minus sine 1/3 pi minus √3/2. Okay, example 2, we have a plus, so that plus goes with that minus, and angle A is 3 theta, and angle B will be phi, so we have this. Example 3, tan, and we've got two angles with a plus, so here's the identity, and so we need a plus on this side, which goes with that plus and that minus. So substituting in, so A is 2 theta, so I need 2 theta here and here, like this and this, and B is 1/3 pi, so I need 1/3 pi here and here, like this and this. The tan of 1/3 pi is √3, so we can simplify, and that's telling us the tan 1/3 pi, so all of this is √3. A common mistake here is to think, well, tan 1/3 pi is √3, so instead of writing √3 there, to write tan √3, and that's wrong. And this is also √3 times tan 2 theta, there it is, √3 times tan 2 theta. So this is now fully simplified.